So here's the agenda. A few words about AI at Amazon. Then we're going to start looking at some high-level services that are just API calls to perform AI services like text-to-speech, image recognition, face detection, face comparison, etc. Yeah, thanks. Okay, so as you will see, they're really, really simple to use. They're based on deep learning, but all you have to do is just call an API. Then we'll go down one level, and we will look at a service called Amazon Machine Learning, which is machine learning as a service, right? So you don't have to worry about infrastructure. You don't have to worry about starting a cluster, managing servers, etc. You just upload your data, build a model, and invoke it to get predictions. Then we'll keep going down. We'll look at another service called Amazon EMR, which stands for Elastic MapReduce. And specifically, we'll run a notebook based on Spark MLlib for spam classification. And last but not least, we will take a quick look at Apache MXNet, which is an open source library that allows you to build and train deep learning models. Okay? And of course, I'll share some links. Of course, you will get the slides. I usually put them on Twitter right after the talk. And all the code that you're going to see is also on GitHub. And the link is in the slides. Okay? So just a few definitions before we start to make sure we actually all talk about the same thing. So artificial intelligence is the high-level discipline. It's been there for decades, literally since the 50s. And the purpose of AI is to build systems that show human-like behavior, right? Systems that can understand natural language, systems that can talk, systems that can show reasoning, intuition, prediction, etc. So it's a very wide field. Within AI, there's a subset that's called machine learning, and machine learning tries to teach machines to learn without being programmed. So basically, you take an algorithm, a standard algorithm, you run some data through it, and the algorithm learns how to predict correctly or to classify correctly based on the data set that you used, right? And then there's the third thing called deep learning, which is a subset of machine learning. So it's the same story. We try to teach machines to learn automatically, but these times we give them data sets that are usually very complex, very large, like images or sound or video, etc. And data sets where features are not visible, right? When you learn from, let's say, weblogs or CSV files or, structured data, it's quite obvious what the features are. When you learn from images and sound, it's not obvious at all. And actually, deep learning is able to find the features automatically. Okay, so we'll cover all three today. AI is a key thing for Amazon. We've been doing AI for a long time, especially on Amazon.com, the retail part of the company. Anytime you go to Amazon, you see personalization, recommendation, A/B tests, etc., etc. So it's AI all over the place on the website, but it's also heavily used on the logistics part. I'm sure you've seen those videos on YouTube where you see the Amazon robots moving around in the fulfillment centers and moving the shelves to the people who actually prepare the orders, etc. And we built some new products like the Kindle and the Echo device, and of course all of those use AI, machine learning, and AWS is now bringing machine learning and AI services to all of you, to everyone. And it's not just Amazon. We have tons of customers. It's mostly a technical talk today, but I will give you some customer examples on pretty interesting use cases for AI. If you're interested in those, you can go to our website and you will find all the use cases and all the stories for this. So here's the current stack. So like I said earlier, multiple levels, high-level services that are just API level, SaaS level services. So call an API, get the job done, and we'll cover a couple of those today. Going down a level, we have platforms like Amazon Machine Learning, Elastic MapReduce, and some other services where you're free of managing infrastructure, right? We manage the infrastructure for you, but you still have the flexibility to build your app, write your code, etc. And then going down even deeper, we have the open source libraries like MXNet and TensorFlow and all the others that you can run, of course, on our instances to build custom models and train them. And at the bottom, of course, we have the infrastructure. We have CPU instances. We have GPU instances. Maybe you've seen we recently announced support for the NVIDIA Volta GPU. So it's available now. I guess we're the first cloud to have them. And you can do also IoT deployments and mobile deployments, etc. Okay, so we're going to look at all of these things. Well, not all of them, a few of those. So first, we're going to start from the top level. And we're going to look at two services, Poly and Recognition. So Poly is a very simple service. It's text-to-speech, right? So you give a text string. You select a voice. We have 50 voices in 24 languages. You call an API, and in real time, you get a sound file with lifelike, so high quality sound. Okay, as simple as that. That's really literally the only thing you could say about Poly. So let's look at an example now. Oh, sure. Before we do that, who uses Poly? Well, we have customers who use it, but I guess this is probably the most famous example. So if you've seen that Echo device before, the voice that comes out, the Alexa voice, and the voices that are used by all the Echo devices, they are generated by Poly, right? So it's definitely production quality. Okay, so let's switch to code. Can you see okay in the back? Yeah? All right. If it's too small, you just yell, right? So here's a very simple example. And what we're doing here is, first of all, we're going to connect to the Amazon Poly client, right? You have to do that for most AWS services. Just grab a client, okay? And here I'm using the EU West region, which is Ireland. And the only thing I'm going to do really is this, right? I'm going to call that one API with a voice. So we have 50 voices and they all have names. So here I'm going to use Brian. It's a UK voice, UK English voice. The text string and the output format that I want, okay? And then I'm going to play it. But with Poly, you can do plain text, but you can also use SSML, which, if you're not familiar with it, is a markup language to provide extra semantics to the text. Okay, so here I'm building a second message, and well, it's SSML, but when you listen to it, it will make more sense. And I'm using a different voice and playing it again. Okay, so let's try this. Let's have some sound. Hopefully, it's going to work. Do we have sound coming out? No. I don't think I have sound. No. Okay, let me try like this.
Hello, my name is Brian. I'm in the kitchen. Your reservation for 2 rooms on the 4th floor of the hotel on the 21st of March 2012, with early arrival at 12:35 p.m. has been confirmed.
All right.
Please call 888 555.
So it's working. But only the front row can hear it. You heard it, right? Yeah, all right. I've got witnesses. Should I try again? Yeah. Okay, all right.
Hello, my name is Brian.
Thanks.
I'm in the kitchen.
Your reservation for 2 rooms on the 4th floor of the hotel on the 21st of March 2012, with early arrival at 12:35 p.m. has been confirmed. Please call 888 555 1212 with any questions.
Okay, so pretty cool. It's much better to have those, for example, the phone numbers. if you have 888, 555, it's easy to say it like that. It's easy to remember. You could also say 888, 555 if you wanted to. But, it's probably easier to remember. And the times and dates, you can make sure they're pronounced exactly the way you want them to be pronounced. Okay. So that's Poly and 24 voices, 24 languages. And there are some more features. Of course, you can change the speed and you can change the pitch. You can do lots of different things. But literally, it's one API call, and you can have real-time speech in your application. Or you could save the sound files and play them in the application as well, of course. Okay, so here's Poly. Super simple. All right, let's move to the next one. The next one is called recognition, and as the name implies, it's going to be used for object detection, scene detection, face comparison, and some alternative use cases like celebrity detection. So you should try it. You should try the Ukrainian football team and see if we actually can detect those guys. I didn't try it. And there's content moderation to detect explicit or suggestive content. And I know I will not show you a demo of this. Okay, you can try it yourself. All right. So here's an example of a customer using recognition. It's a US TV channel. They broadcast all the political debates in the US called C-SPAN. And the problem that C-SPAN has is they want to be able to find a given speaker in their archives. Okay, they have years and years of video archives, and they want to be able to say, okay, Senator X did talk about this specific issue on this specific day, and then this other day, and then a week later, etc. They want to basically to find speakers in their archives. Okay, so until then, they did that manually, if you can imagine that. So they have almost 100,000 people to keep track of. So they have to literally write down. I guess they have a huge Excel sheet or something, hopefully, and they write down all of that stuff. And it's insanely time-consuming. So instead of doing that, they tried recognition. So they built a database with 100,000 faces, right, 100,000 people, and they run their video archives through that. And automatically recognition can find that, okay, this guy here is Senator McConnell, and you can look at the agenda for that day, and then you know what he's talking about, right? So it's now fully automated, and they're actually processing all their archives, right? Years and years and years of archives, going back to probably decades, and being able to now very quickly find their speakers in their terabytes or petabytes of archives. So let's look at a few examples. So the first thing I want to do is object detection. Okay, so here's my picture. Right? Right. It's Oktoberfest, but I'm sure you have a Kiev Fest or something, right? There's something like this everywhere. Okay, so I want to know what's in this picture. Okay? So this is how I'm going to do it. So I have to copy my picture to an S3 bucket, right? I could upload the picture directly, but here it's in a bucket. So again, I've got a client. I'm connecting to the recognition client in Ireland again. And, well, the only thing I have to do is this. Okay, create a request saying, well, here's the image. Give me 10 labels, and give me 10 labels that have at least 75% confidence. Okay? And then I'm calling detect labels, and then getting the result, and just iterating through the labels, right? Want to try it? And if we have the console, it's going to be better, yeah. Okay, so this is what recognition found. So people, person, human, alcohol, drink, crowd, female, girl. Well, sounds like a good definition, okay? And again, as you can see, it's real time. Here, I've got just 10 labels, but I can literally have 100 labels if I want. but then the confidence scores go a little lower. So again, one API call and you get deep learning based object detection, right? It's very fast, it's very easy. You don't have to be a deep learning expert to do this. Now let's look at a second example. Let's try to do face detection. Okay, so we're going to use that same picture and we want to find faces in there and get some information about the faces. Okay, so what does the code look like now? So same story, get a client, build a request. It's almost the same, right? And then I'm calling detect faces. Okay, one API call. And then I'm iterating through those details. I'm going to print out how many faces I found, and for each face I'm going to print out quite a lot of information. So let's try it out. Yeah, quite a lot. Okay, so we found 15 faces, right? Which is the maximum that you can find in a picture. It's a limit that we set, right? It's not a really technical limit. It's, I guess, we don't want to look for 100 faces. So 15, don't ask me why not 16 and not 14. 15 was found to be a reasonable number. And so for each face, I'm going to get some information. So I get, of course, I get an age range, but what I really get is a JSON document with what we call the bounding box. So the positioning of the face in the picture, right? So these are relative values, not pixel values, of course. So the age range, smile, eyeglasses, sunglasses, gender, does that guy have a beard or a mustache, etc., etc. Emotions, and then the landmarks, where are the eyes, where is the nose, etc., etc. Right, it's very funny if you want to add, fake sunglasses, or if you want to do Snapchat-like stuff. It's useful. Okay, so lots of information here. And then we have the same thing for the second face and all the faces, right? So that's recognition for faces. And the last example I want to show you is comparing faces. So let's look at the images. So image 1, that's my reference image. Image 2, okay, am I in this picture or not? Okay. So here, same thing, I'm going to grab a client, and in this time I'm going to actually upload the images. So I'm not, I'm creating an input stream and sending the byte stream directly to recognition, not using an S3 bucket. Okay. Creating a request for this, calling compare faces, and getting results. And that's it, right? So, am I in this picture or not? So, yeah. So in the second picture, again, these are relative values, so it's kind of in the middle of the picture, right? 60% and 51%. So, yeah, I guess here, right? Okay, that's me. I can confirm that's me. Right? So, as you can see, not a lot of code, not a lot of complexity, just grab a client, build your request, send it, and you're done. Okay? And you can get extra information. Of course, I'm just showing the match here, just what I'm interested in. All right? Okay, so let's move on. So there's another service called Lex for chatbots, but in the interest of time, I can't show all of them to you. But feel free to go and check out Lex if you have chatbot use cases. So now going down one level, right? Let's look at Amazon ML. Okay, so the high-level services, like you saw, they're just API services. Now, let's say you want to build your own machine learning model. How do you do that in the easiest way possible? So this service was really designed for non-experts. It's really designed for developers. who don't know much or possibly don't know anything about machine learning, but they've got data and they want to build models. Okay, so it's super easy to use, really. First of all, there's no infrastructure to manage, so that's good. And second, you pick from a small set of algorithms, and they do the work for you, right? So you don't have to worry too much about the machine learning part. It's based on actually a project that has been running in production at Amazon for years and years and years, right? And it became an AWS service in 2015, actually. So it's pretty robust. It's still being used by Amazon today. You can grab data that is already living, of course, in AWS. So you can upload data that lives in S3, RDS, or Redshift. Okay? And the really cool thing is, once you've trained the model, you can deploy it to an API in just a few seconds. It's basically clicking a button in the console or calling an API to deploy the model. Right? And if you've tried to do this before, you know it's the complicated part. Right? I always say the machine learning part is easy because usually it's on your own machine, your own laptop. Right? And then you take that model and you try to put it in production on 100 websites. And it needs to be fast, it needs to be highly available, etc., etc. And then the real problems start, right? Here, this is completely solved in a few seconds. So here's an example of a customer who uses that, FraudNet. So basically what they do is their customers are e-commerce websites all over the world. And they want to help these customers detect fraudulent transactions, right? So if you have a stolen credit card and you order from them and you have a delivery address in the middle of nowhere, that's probably not a good transaction, right? So this is what they do, right? They build machine learning models to detect bad transactions on e-commerce websites. And there's no single model that can find all bad transactions. You need to look at 20, 30, 50 different things, and probably you need to build a model for each of those problems. Okay, and Amazon Machine Learning lets you do that very easily because, again, it's all API driven. It's very easy to create a model automatically, train it automatically, deploy it automatically. So if you want to work at scale, it's very, very comfortable. So let's look at an example. So here, oops. I have a data set. It's a banking data set. It's a public one. And it's got information on whether all these people here, based on these features, are likely to subscribe to a new financial product, right? Are they going to be interested or not in that new offer? Okay? And so there are tons of features, age and work, work type, and marital status, level of studies, etc., plus more features. Okay, and well, we have about 40,000 something. Yeah, about 40,000 samples. Okay, so how can we build a model from this and predict with new samples? That's the thing we're trying to do here. And here it is. So again, in the interest of time, I did prepare a few things. So the steps that you would go through is, first, you would create a data source. Okay, so you would upload that data. And again, here, it's a CSV file, so you can upload it directly. But that data could be in S3. It could be, again, in one of the different backends. So you're going to upload that data. And it's going to perform some quality checks, give you some basic statistics information, etc., on what the data set is. You can explore it, okay? Then you're going to build a model from it. So here, what I want to do is a binary classifier. I want to know if these people are going to be buying that new product or not, okay? So I need to look for a binary classification problem. So I'm going to say, well, in that training set, the attribute that I want to predict is, yes or no, will they buy that product? Okay? So that's the target value, the target attribute that my model needs to learn. Okay? So then I'm going to basically use that data source that I created and let the model train. Okay, and it's really as easy as I say it is. There's really, I'm just going a little fast here, but there's nothing happening besides, okay, build a binary classifier. Here's the target attribute you want to learn. Click, go and do it. Okay, and it's going to run for a few minutes, depending on how much data you send, and then you get an evaluation. Okay, so you get the Amazon machine learning is going to keep some of the samples and to exclude some samples from training, right? And it's going to use them for evaluating the model. Okay, so I get different quality scores. For example, for classifiers, the AUC indicator, area under curve, is a good one. So the closest it is to 1, the better, right? And I can look at this evaluation and say, yeah, okay, actually, this is an interesting model. Okay, so I can get some stats and some graphs, and I can adjust the thresholds for the model. Come on, Wi-Fi. All right, let's try that again. Oh, here it goes. No? Come on. Okay, well, not today. The curse of Wi-Fi. Okay, no worries. So you see a graph, and you see, the area under curve, and you see the false positive and the false negative, etc. And you can adjust, right? You can adjust for that. Okay. And now, basically, once I've done this, I've got a model. I know how good it is, and I can deploy it. Okay. So I could generate batch predictions. I could upload another CSV file missing that target attribute, and predict all of those values. Or I could just click here and deploy my model to that endpoint. And again, this only takes a few seconds. And now I can do predictions, right? So you don't have to worry about deploying that to a website or anything. It's done automatically. So what does it look like? So this is what it looks like. So here my model has been deployed behind that API, and I want to use it, okay? So I'm listing all my available models, printing out some information for the model I'm interested in, okay? So we'll see some information there. And then the interesting part is this. I build a prediction request. I assign it to that endpoint, and then I build my sample, right? And you have to love or hate the Java API here, right? I have to say in Python it's a little easier to do, but okay. The builder pattern is, I don't know, it's there to stay, I suppose. So you have to call add record entry a million times to add all the attributes for that, new sample, okay? And then you basically just call predict with the request. And that's how you invoke the model, okay? So let's try it. All right, so I see some information about my model. I see it's a binary classifier. I get my endpoint here. And I get my prediction results. So the actual score was very low, 0.02 something %, which, I decide to set as a 0 because it's so low, right? It has to be 0 or 1. So my threshold here says, no, that's a 0, okay? And that's all there is to it, okay? And once again, if I had time, I could show you the whole thing from scratch in probably 15 minutes, right? Create everything from uploading the CSV to doing this in 15 minutes, maybe less. So no infrastructure to start, no infrastructure to manage, no expert machine learning knowledge required. Just go and do it, right? And you can build regression models, and you can build classification models. Okay. So if your use case is exactly this, there is no faster and simpler way to do it, right? But sometimes your use case is a little more different, a little more complicated than classifying or predicting numerical values. And then you have to go a little deeper and build your own model and your own code, and you cannot rely on a managed service. Okay? And so when you have that kind of need, then probably the right solution would be to look at Amazon EMR. So Amazon EMR has been around for a number of years now, and it's basically a managed service for all the Hadoop apps. So it started with MapReduce, and then Spark, and Hive, and Presto, and Impala, and Flink, and God knows what else, we keep running after all those Apache Hadoop apps, but they're all in there. It's the cloud, so it's elastic. You can launch a cluster in a few minutes. I'll show you how to do that, maybe less than a minute. You can choose between our open source distribution, which is pretty much the Apache distribution, or the MapR distribution if you're interested in that. And then you get all the good stuff, pay as you go. Now you're paying by the hour, or can you pay? No, you can pay already. I think you can pay by the second now. I think EMR is part of the second pay by the second thing. You can use spot instances to save a lot of money, right? So you get all the good stuff that you already know from EC2 and so on. Okay, but it's not just that. You can also benefit from multiple integrations. So if you have data that lives in, for example, DynamoDB, there's a connector to upload it. If you have data in RDS, there's a connector. If you have data in Amazon Elasticsearch, there's a connector. If you have data in S3, you can directly load, read and write data from S3. You don't have to load it or read it in HDFS. You can connect to Kinesis if you have streaming use cases. And you can also read it from Redshift. So that's the interest also of EMR, is that it's going to find your data in AWS, in all those backends, and it's going to make it very easy to load it, right? So you don't have to worry too much about writing scripts and doing the loading yourself. All these connectors and all the training, all the tutorial codes, etc., will be there. Okay. So when it comes to Spark specifically, which we're going to look at in a second, there are multiple ways you can submit a job, a Spark job on EMR. You can use the EMR API, where we have what we call the STEP API, which is a way to start a cluster and get it to run a job or a sequence of jobs automatically. And you could say, once the step is complete, just terminate the cluster, right? So it's really on-demand clusters. Start a cluster, run that job, terminate it when the job is over, right? You can automate quite a lot of things here. You could use AWS Lambda to trigger jobs, and then you could use other services like Glue or Data Pipeline to build, to integrate Spark into your ETL workflows. And of course, you could be running your own schedulers on EC2 instances. If you want to run Airflow, you can do that, and it's going to connect to the Spark cluster. And if you want to experiment, you can also use Zeppelin, which is included in the EMR distribution. So when you start an EMR cluster, actually Zeppelin is pre-installed, and you can connect to it. Okay? So let me show you how you start a Hadoop cluster. I'll do it in the console, but where is that thing? Here. But of course, you can do this with APIs. Okay? So let's count the clicks. 1. I want Spark. Okay. 2. 3 nodes. You can choose different node sizes here. But okay, let's have something nice here. M4. Let's select a key pair, SSH key pair to connect. So how many clicks is that for? 5. Done. wait for a few minutes, and your EMR cluster is ready to work. Okay. And of course, it's 5 clicks, but it's one API call, right? If you call the create EMR cluster, it's one API call with those 5 parameters or something, right? So wait a few minutes, and you have a cluster. So I don't want to wait for a few minutes, so I already have a cluster, but I did the exact same day. I launched it the other day, and it's got Spark running. So how do you connect to that? So first, you need to open an SSH tunnel to the cluster. I could SSH directly to the cluster, but here I want to see Zeppelin. I need to have the web app, okay? So I have a tunnel to that cluster. I need to set my proxy here to use that tunnel. And hopefully I see my notebook. Yeah, all right. Okay. So let's clear the output. Okay, so it's Zeppelin running on my Hadoop cluster. Can you read it? Yeah, in the back? Or yeah? Oh, you have screens on the side. Okay, that's good. So Zeppelin notebook running on my cluster. So here I'm going to build a spam classifier. Okay, so let's run some imports. I'm going to load my data set. So I have 2 text files. One with one with correct content, right? So it's 1 line per message, and one with, well, spam and crappy content. Okay, so I'm going to load those. And as you can see, they're hosted in S3, right? So we pull them directly from S3. I'm going to map the features. So I'm going to extract 1,000 features from those data sets, so 1,000 words, right? The most meaningful 1,000 words that help me understand if it's spam or if it's correct. I'm going to build my data set here, right? So the positive examples, so all the features that are found in the spam messages are going to be labeled with a 1, meaning it's spam. All the features in the correct messages are labeled with a 0 to say no, it's not spam. Then I'm splitting my data set. I want to keep 20% for evaluation, so I'm going to train on 80%. And then I'm going to train a number of models. Okay, so that's the Spark ML API. So I can try an SVM model and see how well it does. Accuracy is not bad, but area under curve is too low, so that's probably not a good model. Okay, I can try another algorithm, logistic regression. Good accuracy, slightly better AUC. Let's try a decision tree. Yeah, not great. Let's try a variant of trees. And as you can see, right, here I've got a small cluster with 3 nodes. I could have a cluster with 100 nodes and crunch huge data sets, and I would still be working in my notebook, and I literally don't worry about infrastructure, right? That cluster could be managed by your ops team, and you would just connect to it. And as a data scientist or as a developer, you don't need to know what's behind this, okay? And again, it's all pre-installed. Okay, so this was a little longer. Hopefully it's a little better too. Yeah, okay. But then naive Bayes, I guess, is the answer for spam, and yeah. Okay, best accuracy, best AUC. So it's like the hello world for classification, right? I'm sure you've done this one in school. A naive Bayes for spam classification still works the best. And so we can try new samples. So here's a message, right? So this is let's say that's an email I got this morning. I want to know if it's good or not. And let me be very clear, I have nothing against the good people of Nigeria. It's just an example. And here's another message. So let's take those messages and run them through that Bayes classifier. And yeah, the first one is definitely spam and the other one is not. Okay. So here's an example of using Amazon EMR with Spark, and actually Spark ML and Zeppelin to get the job done, right? And you can see how easy that is, right? Again, if I could do this from scratch, the cluster is probably ready now. We should check. Yeah, see? Well, let's just refresh the page. Yeah, so the new cluster has been ready for 5 minutes, right? So again, in the interest of time, I did create a cluster, but it really takes a few minutes, and then you connect and you start working. Okay, and when you're done, you just terminate it. So I would just say, okay, I don't need this guy anymore, just terminate it, and stop paying. Okay, so pretty cool, right? And if I need 100 nodes, I just ask for 100 nodes. Okay. All right. Let's keep going. Okay, so that's where we are now. So let's go down one level, okay, the last level. Now, you want to go into deep learning, okay? The examples that I showed you before in Amazon machine learning, the features were very, very clear, right? And in that Spark example, the features were very clear too, even though they were computed automatically. But now, let's say I want to do, image recognition. That's more difficult. Okay, what are the features? I give you 1,000 pixels by 1,000 pixels image. What are the features? Are all the pixels a feature? Do you have 1 million features? No, probably not. Okay, so if you try to use traditional machine learning algorithms on that kind of content, it's not going to work. And this is where deep learning is going to help. Okay, so here I'm going to show you MXNet, which is our preferred library. It's our preferred library for a number of reasons, because it has the widest language support. You can do Python, C++, Scala, R, Julia, and probably more. It works pretty well in embedded environments. I've got a very nice demo with a Raspberry Pi, where I have a deep learning model running on a Raspberry Pi, and it works fine. So it doesn't have to be a huge machine to run MXNet. And it scales very well as well. If you need to run very large trainings, you can scale linearly. So if you have twice the number of GPUs, it's going to be twice faster. If you have 16 times the number of GPUs, it's going to be 16 times faster, right? And it scales almost linearly to 256 GPUs. So if you have huge data sets, images, videos, etc., and you train on a small number of GPUs and it takes days and weeks and it drives you crazy, you can use MXNet, add more GPUs, and save some time, okay? And last but not least, it's part of the Apache project, which we love. Because it means it's very independent, right? So it doesn't belong to anybody. We've got committers from Apple and AWS, of course, and from the research community and from universities. So a lot of people contribute to MXNet, but it's managed by Apache, so it's independent. So again, I don't have much time, so I'll show you a simple example. It's probably the hello world for deep learning. It's the MNIST data set. 60,000 handwritten digits, and of course the game is to show digits to the model and have the model tell you that it's a 0, 2, or 4, or 6, or something else. Okay? So let's take a look. And I won't go into all the details, but I'll point you to more content if you want. So here, now I'm not working on my Mac anymore. I'm working on a GPU instance. And this one is the bigger one. It has 16 GPUs. So it's a nice toy. I'm glad I don't pay my bills. And so this is part of the MXNet distribution, actually. And I just want to show you quickly just a bit of code. No, that's the other one, sorry. Yeah. just to show you, to give you a sense of the MXNet API. Okay, so here I'm building a model. So it's a simple multi-layer perceptron. So I can define each of those lines here is basically defining one layer at a time, right? So programmatically, I'm able to define my network. Okay, here's another different type of network I could define. Okay, here I'm loading my data. So I've got, actually there's a pre-built object for that data set. So I can load my data, my training data set. I can load my validation data set, etc., etc. So it's not a ton of code, right? It's not a ton of code. Okay? So let's do the training. And you will find some Scala tutorials on the MXNet website. So let's actually go back to here. Come on. Okay, and I pre-built all that thing. And here's how I'm going to launch it. Okay, so I've got my data set up here, I think. Yeah, okay, that's my data set here. And I'm going to use that simple multi-layer perceptron network. And I'm going to run that training on CPU because it's not a very large data set. And let's see what happens. Okay. All right, so here I'm running on CPU. It's still quite fast. I'm learning about 3,000 samples per second. And you can see the accuracy going up as the network learns how to correctly predict the data set. Okay, and after one epoch, so one round, you can see training accuracy is 96% or something. Where is it? Yeah, here. Okay. After two epochs, it goes up a little bit, right? So if I run this on GPU, it would be done already, okay? But it goes so fast that we don't even see what's happening. Okay, so I can see again my training accuracy going up. And we will get to, I don't know, 97 or something, yeah, 97%, because it's a very basic network. Okay? And then I could save that model and I could use it to predict. And again, this is a very basic example, but you can build very, very complex models, and you can reuse very complex models with MXNet. Okay. All right. It's going to finish in a few minutes. And I can see accuracy. Yeah, probably, maybe we'll get to 99%. Who knows? Okay, so a very, very quick look at MXNet. Some more tutorials and information here. The one last thing I want to say is if you want to experiment, it's possible to run MXNet on Spark. It's a bit experimental, but it's actually pretty interesting because you can have one single cluster, so you could start an EMR cluster using GPU instances. We support that. And you could use the same cluster for data preparation with Spark, right? So do the ETL stuff with Spark, and then have the data locally on the cluster, and then immediately start training. Okay? So you don't need to have separate infrastructure for data preparation and deep learning. Okay? So feel free to try it. It's experimental, but I guess the basic use cases probably work. And if you want to contribute, you're more than welcome. So this is the very quick trip through the Amazon AI stack, from AI, high-level AI services to platforms to deep learning with open source libraries running on CPU and GPU instances. And as you probably know, we have our annual conference, reInvent, in just a few weeks now. And it's usually where we make a lot of announcements. So probably this is going to change quite a bit, right? So if you're interested, keep an eye on the reInvent announcements, and you will see some more stuff. All right, so good resources. So of course, the AI, machine learning, and EMR web pages. We have dedicated blogs for big data where you will find lots of EMR stuff. We have an AI blog where you will find, again, Spark ML, MXNet, etc. We have SDKs for Java and Scala on GitHub, right? So if you want to write the Java APIs and the Scala APIs that you saw me using today, they come from there. And if you want the code for all of this, that's where it lives, okay? And I'm done. Thanks very much. And if you want to follow me on Twitter, if you're interested in AI and machine learning in general, please follow me and you will get lots of good content and good articles. All right, thanks again. If you have questions, I'm happy to answer them.
Hello? Does it work? Hello. Thank you for a good article. I have a question. For example, I have use case with support. We have a lot of questions to support, and I want to build some bot that will answer this question.
Yep.
Which level should I choose? It's machine learning or deep learning?
Interesting question. So the question is, we've got tons of questions coming for support. We want to build a bot to answer it. What do we choose, right? So actually, I would probably choose a combination of both. I would choose Lex, right? You need to look at Amazon Lex. And it makes it very simple to define the conversation. No infrastructure to manage. Basically, questions, answers, questions, answer. Very simple. Okay? So to define the conversation, I would use Lex. And then during that Lex conversation, you can actually call, for example, Lambda functions. So you could take the question coming from your user, right, through Lex, call a Lambda function that would invoke maybe a machine learning model to say, you know, like the spam classifier thing, right? Is it a network problem? Is it an Excel problem? Is it an email problem? You know, to basically be able to point the user to relevant answers. Right? So you could build, if you have sentences from your users, right? You could build a data set and say, okay, that's an email problem, that's a network problem, that's an internet problem, that's the problem is between the user and the screen and the chair problem, you know, et cetera, et cetera. Then build a data set, train a model that would be able to classify based on that sentence, and call that from a Lambda function triggered during the Lex conversation. That's what I would do. I'm quite sure it will work.
Okay, thank you.
Thank you. Good question.
Hello. There was a definition of artificial intelligence on one of your slides. So how do you think, how do you understand intuition when we say about artificial intelligence? Thank you.
Yeah, it's a good, the question is, what does intuition really mean in the context of artificial intelligence? So here I showed you some examples of training models using techniques that are called supervised learning. Okay, so supervised learning is I show you a data set with the correct value and you learn from that, and I show you new samples and you predict. Okay. There's another class of learning that is called unsupervised learning, where, for example, clustering is an example of that. Clustering data based on similar attributes. And this is an example of unsupervised learning. So you don't train, you just take an algorithm and throw data at it, and well, if it's working correctly, you know, it's going to learn how to cluster, for example, right? And so then, when you query it, okay, you get an answer back. Say, okay, now I show you this new sample. Tell me what cluster it's part of. Okay, so you could call it prediction. I like to call it intuition because you know it's not based on learning from something that humans defined. It's based on math and statistics, but at our level, right? It's intuition. It's like, give me the answer to this, and it's like you look at the answer, and it's like, yeah, it's not bad, right? Good question. Thank you. No more questions? All right. Well, if you have questions later on, just ping me on Twitter, and I'm happy to answer. All right? Thank you very much.